All right, what is up? Today it is part 3 of the RISC-V and RARS series. We'll be looking at how to read, print, and handle conditional statements. We'll go over some terminology, we'll look at some instruction structures, and we will step through this little bit of sample code that we got here and see how things change as we run through the program. A lot to do. Let's get to it. So first things first, let's give credit where credit is due. This fellow, John Wenskovich, is perhaps a professor or someone with PhD status at Virginia Tech who has a pretty good series of videos. They're a little bit long and, they're a little extensive, so it's kind of hard to get the information you want exactly unless you're following the course. Not that they're bad videos. So let's try and condense that and add a little more information that is more relevant to actually doing stuff instead of learning the overall structure. Not that one is better than the other. We also have some sites here from GitHub, some official instructions, some additional information from other college resources, and some full instruction overviews, as well as official documentation that I will all post in this markdown file, which I will upload to the GitHub that has the ongoing information for RISC-V. All right, so let's look at this piece of sample code here. Start from the top and go to the bottom. We have two sections, the data section and the text section. These are assembler directives. They point to blocks of memory that contain information. The data section is a block of memory that contains all the variables that we'll be using that will not fit in registers. In this case, there's strings, and there's 3 of them. The text assembler directive is the same, except it's a block of memory containing the program and the instruction. Inside the data section, we have the ASCII Z's. These are strings that are followed by a 0 byte. This is a pointer to the first location in each of them. They're stored in a continual block, but there is the 0 byte to differentiate them or to separate them. And then in the program memory or the text section, we have 4 instructions. We have the add/add-i. I have explanations of that in the part 2. We have the LA instruction, which is loading the address, the ecall instruction, which is the environment/system call, and the BNE instruction, which stands for branch not equal. Let's go into each of those individually. All right, let's start with this block. There are 3 instructions here. The add-i, which just takes the second and third, or the first and second, depending on how you're counting, and adds them together. This is the 0 register. So we're adding 4 to 0, and we're storing it in register 17. Now, these registers are important. The 17 register, or the A7 register, is for arguments, and the X10 or the A0 register is also for arguments, but the return value, or where things will be stored or where things should be. So here we are storing 4 in the A7 register, and we are going to load the address of the string block of memory into the X10 register, and then we're going to run the ecall function, which is going to the ecall instruction, which is going to check for the code and perform the operation. Let's break that down a little more. Okay, so maybe a little bit out of the scope of the video, but the structure of a basic instruction or one of these lines is a 32-bit space that can be handled. So if you want to load an address, the address is 32 bits, so that is too much for one instruction. So the load address instruction is actually a pseudo instruction that is split up into 2 parts using the AUIPC instruction and the add-i instruction to load a portion of the address and then the rest of it, and that's all handled in one instruction. The main thing here is the number 4. So looking at the ecall instruction, there are a bunch of different codes that perform different things. 4 corresponds to print string, and it is required to be in the X17 or A7 register. So the ecall function is going to look in the A7 register, determine that it is a print string instruction, and then look in the X10 register for the pointer to the string in memory. And then it's going to print this string. All right, the next block is another ecall, and we have the number 5 getting stored in the A7 register, and the number 5 corresponds to reading an integer. So after we print this string, which looks like it is n equals space, n space equals space, we are going to read in a string, and that is going to be then stored in the X10 register. Once it is stored in the X10 register, the add function is going to add 0 to 10, or 0 to the value in the X10 register and store it in the X26 register. So that's just a way to store the variable somewhere where we can use it. You don't want to keep it in the X10 register because that is for arguments. All right, and the last block before the loop is setting up the actual variables that we will be using for doing the program. We're going to establish value in the X27 register, which is just going to be 0, and a value in the X28 register, which is going to be 1. All right, so I went through that pretty slowly. Hopefully you understand how the ecall function depends on previous instructions to do the proper task. That's the main section, and now we have the loop section, which has similar instructions but has a conditional here to do some interesting things in the loop. All right, so to start off the loop, we are going to perform an add on saving the value of the X27 register and the X28 register back into the X27 register, and then we are going to add 1 to the value in the X28 register and save it in the X28 register. Then, after we do that, which is just an increment on both values, we're going to run the BNE instruction, which stands for branch not equal, and that is going to check the first register and the second register values here, 28 and X26, and is going to check if they're equal. If they're not equal, it's going to go to the location here, which is loop, and that is the beginning of the loop. Remember, the X26 register is where we saved the entered value. So this could be anything that you enter. And we will see that if you don't enter anything, it's just going to store what was originally in the X10 register. I'll do that in the second video where I will actually step through the program in the execute section. You'll see that there are no checks for any kind of errors here. This will just run and do what it does. All right, so after the loop runs, and the loop will end when the value in the X28 register equals the value in the X26 register. Once that happens, we have another ecall instruction with the code 4, and the code 4 corresponds to printing a string. So we're going to print the string in the, we're going to store the instruction in the X17, in the X17 register, and then we're going to load the address of the string S, which is a few spaces, maybe 4, an S, an equal sign, an S, a space, an equal sign, and then we will run the ecall instruction, which will print the value in the X10 register after checking the code in the X17 register. And then after that, we have two instructions we've already seen before. We're going to have the number 1 stored in the X17 register, and we're going to have the value in the X27 register stored in the X10 register, and the ecall function is going to check the code in the X17 register and return the value in the X10 register, the 1 code corresponding to the print float instruction. Now, we shouldn't have a float because we're only incrementing by 1, but the string n value, the read instruction, again, does no error checking, so it's potentially possible that someone enters a float. So it's probably a good idea to use the print float instruction over the print int instruction, which is specified in the comment. And finally, we are going to store the code 4 in the X17 register. We are going to load the string.nl variable, or string, in the X10 register, and we're going to call the ecall function, which is going to check the X17 register, see that it's the code 4, which corresponds to the print string instruction, and print the string that is pointed to by the X10 register. That happens to be a new line. So all in all, it looks like we are going to print a sort of prompt to enter a value, then we're going to read in a value, then we're going to increment, then we're going to instantiate 2 variables, and we're going to start a loop. That loop is going to increment the S value and the I value, and it's going to check the I value against the entered integer, or whatever you put in, and then it is going to repeat that until they are equal, as I said before. Then it is going to print the S value and a new line. That's basically it for the walkthrough. In the next video, we're going to go through the execute here, and we're going to see the registers update in value, and we should also see the values in memory, which is the data segment, change as, or maybe not. We'll see. Who knows? Hope you liked this video. A little boring, but should give you a good overview of the LA instruction, the ecall instruction, and the BNE instruction. And this documentation will be in the GitHub and should also be helpful in giving you some basics. Like and subscribe, star the GitHub. Hope you have a great day. Stay tuned for part 4.